In this video tutorial, we're going to illustrate how to use the Adapt Builder wind load wizard to apply automatically generated wind loads on multi-level structures. We're going to be using this model, which is a multi-story model. It's fairly simple in terms of the plan geometry at unique plan levels at the base of the structure and the upper set of levels of the structure. We're using Adapt Edge, Floor Pro, and PTRC to generate these wind loads, and a couple of interesting and important points related to any lateral load in the program. If we go over here to load cases, you can see under building loads we have two seismic building loads created, EQX, EQY. And any building load is required to be solved when we're working here in multi-level mode. So we're currently active in multi-level mode. If I switch this to single level, the current plane selected is plane 2, and I can always go and modify the selection for the plane. Now, if I solve this plane independent of the global structure, building loads will not be solved when we're working in single level mode. So going back to building mode, when we add wind loads to the structure, those are going to be stored here, and any load combination that includes wind or seismic in this case would be required to be solved using multi-level mode if we want a solution for those particular load cases that are included in combinations. Gravity loads, self-weight, dead, live, and those types of loads that are classified as general loads will always be solved regardless of the mode that you're working in. We're going to now jump over here to loading, lateral / building. This is the panel that has different wizards available for adding loads. We're going to talk specifically about the wind load wizard panel. And the wind load wizard just collects parameters, input tools, both automatically generated and also custom or manually generated to produce, number one, wind pressures, which are shown at the bottom left. These wind pressures are used to produce forces leeward and windward, and ultimately those forces are then used to produce line loads on slab edges as externally applied loads that represent the wind load cases. So the the primary tools used for load generation are ASE 7. There's also an Indian standard as well as user defined. If we jump over to user defined, the user would then enter the primary wind direction for the loads that are going to be applied or written in by the user, where you would input the windward pressure, leeward pressure, and height in this table. Those are then again converted into forces. If you want, you can just directly override the forces and come into this table and input wind loads. You can also include the effects of torsion, adding some percent eccentricity relevant to both directions of input. So here the primary wind direction is 0 degrees. If we consider the orthogonal direction, we're also considering 90 degrees, and these angles correlate back to the global axis. So our positive directions here, this would be positive x 0 degrees, positive y is 90, and then if we take, for example, 180, that's negative x, 270 would be negative y, and we could also assign any angle in between these quadrants. So we could do a 45, 135, and so on. To give you an example of that, if I go back to the automatic generation, we're going to go ahead and enter some parameters here relevant to this selected design tool or design code. And we're going to use 0 degrees and 90. So this is just going to be positive x, positive y, and we're going to avoid using the eccentricity for this moment. So we can go ahead and enter our basic wind speed and other parameters to produce the lateral resisting system. For an enclosed structure, we're going to produce those wind pressures and forces. And when I do this, you'll notice we're going to create new load cases. So the program will write two new load cases, P0, P90, and I could go ahead and apply those forces. When I apply these, the program goes from bottom to top and then writes in the loads. Now these loads are similar to as if the user went and manually applied these line loads on the structure. If I go back to single level, for example, and I just double click on this load. This represents a windward load acting on this slab edge associated with load case called wind P0, and the magnitude of the load is 193 pounds per foot. On the opposite side, this is also associated with wind P0, but this is the leeward load. And then we have the P90 load here, windward and leeward. These loads can be deleted, they can be moved, they can be modified by the user. It's simply just an externally applied load at this point. You'll notice that those loads get dumped in here to the building loads, written as P0 and P90. Now if I wanted to add the opposite direction, I could do that inside of load combinations by just including positive and negative values for the load factors applied to these particular wind load cases inside of my load combinations. So there are options to do that once we actually assign load combinations to this list under wind P0, wind P90, or I could also come back to the wind load wizard and I'm just going to directly calculate the line loads for those combinations. So I could say I want to use a combination of 180 and 270, and we're going to create new load cases. Make sure you toggle that, and if you update, it's going to update what's already written. And so here we want to add to the list, and I can go back now and apply forces. And now I have 0, 90, 180, 270 applied, and those forces are again added to the list of buildings. If we go back to the wind load wizard, we're going to first go back and clear our load cases. So let's actually delete these load cases. Once we delete them, it'll delete all of the line loads associated with them. We're going to look at a model here with wind P0, P90, and we're going to introduce the eccentricity, 15% eccentricity for both wind directions. So we'll come back to the wind load wizard, and in the wind load wizard now I'm going to use again 0. We'll have 90. We're going to include eccentricity, so that includes this wind M0 and wind M90. And the way that those forces, or in this case moments, are produced are using equal and opposite line loads. So if I go to a particular level here, let's come back up to this level, and I'm going to, using my visibility for loading, I'm going to go ahead and turn everything off, and I'll go back to the view load settings. Under line load, we're going to look at wind M0. And for wind M0, we can see we have a load acting here. This particular load, if we look at magnitude, is 0.116. This is also 0.115, 0.116, and then this is going to be in the negative direction, same magnitude. So we calculate the required moment, and then we actually produce that moment using these line loads, which cause the twisting effect relevant to the input for eccentricity. So that's how the M0 and M90 load cases are established. Now these load cases ultimately have to make their way into load combinations in order to produce a result that might be meaningful for example, for drift check or for design of a frame, diaphragm, or maybe the foundation or other vertical components like columns and walls. So ultimately we need to go over here to load combinations, and in this case we're going to go through and we're going to save this as a separate set of combinations. So what I'll do is actually just delete out a few of these combos. Let's delete out this dead load only, and I'm going to delete the seismic combinations out of this list, and we're going to now resave the model. Okay, and looking back at the load combinations list, if we expand this and open up this dialog window a little bit wider, and I just go ahead and filter by load cases, you'll see that all of the wind load cases are written here. So the program requires the user to then go and produce combinations where the wind load cases would be in combination, for example, with self-weight, dead, live, etc. And those might be related back to the ACI code or IBC codes in order to determine which load combinations are required to be evaluated at service level and or at strength level. Now, one nice feature would be the ability to import an IMP file to actually write these combinations for us. So what we're going to do in this case is we've already written combinations, for example, for ACI that include the effects of wind and seismic. And it's important to note that the combinations that we're going to import include and they reference these names: wind P0, P90, M0, M90, EQX, EQY. If these names differ from a file that you're importing, then what's going to happen is the program is going to produce a new set of load cases that carry the name of those defined in the IMP file. So you need to have these names correlate in this case. So I'll go ahead and just cancel. I'm going to use file import. I'm going to file an IMP, or excuse me, import an IMP file. Okay, and we're going to use this option for master loading ACI. And when we get into the import options dialog, we don't really want to import or update the geometry of the model. We just want to import load combos. So we're going to deselect. We're going to use the update option. I'll turn off merge slabs and deselect any component that might be selected. There are no components that are selected here. I don't want to import any new load cases. I only want to import my load combinations. And I'll select yes. I'll select OK. This is just saying that there's already a combination called initial. Do we want to replace this with the one that we're going to import? We'll say yes. And that will then update the model. Let's go back to multi-level. This will update that list of load combinations that we have included. And now this list could then be exported. We have two options. We can export this as an IMP file, where we can then reuse the combinations from this model, or we can, I should say, or we can save this as a project template, where I can name the template and I can decide which of these three options we want to store as part of that template. One of them is load combinations. So if we go back to the load combinations list, there's now 243 combinations in this file. And if you're interested in the file, you can always contact us at adaptsupport@risa.com, and we'd be happy to send this file over to you. The user will need to make sure and verify combinations and the factors. Some of the factors are specific in terms of seismic. They're site-specific factors, so you need to make sure that those are in correlation with your actual design and location of your design. So these are the combinations. We have our original set of combos here. These are mainly gravity-driven combos, and then we have our wind combinations. If we look at ASE 7, for example, we have 4 wind cases that could essentially produce multiple permutations, and these are those permutations for each wind case. So for example, we have wind in the X direction, positive, negative, wind in the Y direction, positive, negative, 3.75 times wind in each direction, positive, and then negative, positive and negative in the with reference to the Y direction. And all of those load cases are listed here. These are set to no code check. These are really for investigative purposes, to just produce a result for the wind load specifically with no additional load applied. And then we have our ultimate limit state combinations, the referenced with the wind included, kind of built into those combos, and then our service limit state combinations. And you can see there's some seismic ULS and SLS combinations here. So the user then can choose which of those combinations ultimately to design for, to run in the analysis, maybe to check drift for, if we're specifically interested in drift for a particular model. So once the user has defined the wind loads, the wind load cases through the wizard, defined the wind loads in the load combination generator, ultimately we would then be able to take this model, mesh the model, execute the analysis, and produce our desired results after those two things are done. If you have any additional questions on inputting wind loads using the wind load wizard, please contact us at adaptsupport@risa.com.